Welcome to the Environmental Transformation Podcast, where we bring you interviews with industry leaders, climate champions, sustainability practitioners, EHS and hazmat professionals making an impact in their businesses today. Each leader solving complex challenges and delivering solutions within their areas of expertise. I'm your host, Sean Grady, and thanks for joining us today. Before we jump in, make sure to follow us on your devices and visit my website at www.seankgrady.com and sign up for our newsletter and email announcements. Now let's get started. Welcome to the Environmental Transformation Podcast. I'm your host, Sean Grady, and today's guests are Dr. Kevin Aikman and Dr. Ashok Dastidar. Dr. Aikman is a plant biologist by trade. He's from Southern Illinois University in Carbondale. That's where he went to school. He's a certified industrial hygienist, and he's also participates as members of the AIHA and the ACGIH organizations. He's a professional licensed asbestos and lead mold person, and he's got over 30 years of professional consulting experience. And he's a principal at Rambo. And then we've got Dr. Dastidar. He's vice president of Fauske Associates, and he also provides dust and flammable testing and consulting services. Dr. Dastidar, he specializes in chemical process hazard analysis, flammable dust, liquid and vapor explosion, and combustible hazard analysis and testing and electrostatic hazard analysis. Man, that was a mouthful. You guys doing a lot of testing, a lot of high level industrial hygiene stuff. And I really appreciate you guys coming on to the show. And today's episode is the 100th episode of the podcast. Yeah, we are so excited to have you. This is kind of what I'm calling the lost 100th episode for our listeners, for the listeners who are just joining in a couple weeks ago. We actually recorded this episode live in person, and we actually did it twice because we had technical difficulties the first go around. We realized that I had technical difficulties. We re-recorded the second time, thought we had it. Unfortunately, we didn't have it. Or should I say, I didn't have it. And so we're redoing it today. So, gentlemen, thank you for coming back on the show and doing the interview one more time. This is third time's a charm, and looking forward to diving in.
Thanks, Sean.
Okay, so here we go, guys. Let's dive in. For the listeners who may not be familiar with combustible dust, I mean, a lot of people are like, combustible dust? What are you talking about? Like, dust actually catches on fire? Really? Come on. Is that something? Yeah, it is something. So what is it? How does it become combustible? And what types of dust should one be concerned with?
So, combustible dust is typically combustible. So anything that's organic in nature, and even some metals that can form oxides, whenever they're finely divided into powder, think more like particle size of flour or fine sugar. There's enough surface area there for a really rapid reaction. And it's that rapid reaction that causes that explosion. And if it's suspended in air as a cloud, it'll react violently. You'll get a very loud flash fire. And if it's inside of a container or something, you'll get pressurization and an explosion. If that material is left on a surface somewheres and it's exposed to either a hot surface or an ignition source like a spark or a flame, it can catch on fire as well, just like you would with sawdust explodes, wood as a log or whatever will burn.
And it doesn't take much energy to ignite a dust fire either, correct, Doc?
Correct. It could be on the order of millijoules. You and I walking across the carpet, touching a doorknob, can generate around 30 millijoules. Some dust that are like fine pharmaceuticals or fine polymers can ignite well below that, 3 millijoules, 1 millijoule. Certain other materials like sawdust or coal dust are up there around 300 millijoules, 1,000 millijoules.
Well, when we talk about these millijoules and things like that, but let's break this down. I mean, is it because they have an electrical charge on the dust particles themselves, and that's why they can combust, or is it because they actually have a flammable component to it? So any little ignition will just make it like pop and flame. What are we talking about? Why is it so combustible?
So primarily it's because of the nature of the material is very combustible in that it can form an oxide. So carbon-based materials like wood, pharmaceuticals, polymers, plastic. As soon as they heat, they'll go to carbon dioxide and water. So that's why they're combustible. But if you flow powders or manipulate powders, they can knock electrons off the outer shell of the powder and then creating a positive or negative charge. And then when these powders settle someplace, they try to equilibrate the charge and they create their own ignition source. So you can suspend a cloud, it'll get charged, it starts to settle on its own, and you can get a discharge. And if it's strong enough, you'll ignite that cloud.
And a lot can be related to the processing of a chemical too, right? As you make it a smaller particle, or you reduce the moisture within the particle. If it's organic, you could also increase the probability of it becoming combustible or combusting, spontaneously combusting.
Gotcha. Well, I mean, so yeah, we're diving in the weeds here, but that was some good explanation here, because I think a lot of people just kind of want to know, like, well, how does this actually happen? And so what's the role of, Kevin, this might be for you, what's the role of an industrial hygienist to assess combustible dust?
Yeah, the classical definition of industrial hygiene is analysis, recognition, evaluation, and control. So a lot of times the industrial hygienist will be the first person within a facility that might recognize this. And I think a lot of certified or industrial hygienists don't always understand the properties of what a combustible dust is. A lot of people do. Hopefully that's why we're having this podcast, so they understand. But the industrial hygienist can come in and assist looking for those sources within the facility. We conduct air monitoring. We do exposure monitoring typically, right? But if you notice, you can write your name in dust on a surface and that dust may be combustible. And you could review a safety data sheet and get some, and sometimes you get that information. Sometimes you don't. Wouldn't you agree, Ashok? Sometimes they don't have all that information.
Having information if the information is incorrect.
Right, exactly right. We can help evaluating those characteristics of the dust, the particle size, ignition potential, things like that, control measures. Obviously, the engineering controls are important, but we have to be careful as industrial hygienists if we try to over-engineer something and we don't have the background and the experience that Ashok has. You could create more of a hazard. And I think we'll probably talk a little bit about that later. But we look at things like that we can evaluate the ventilation. We can look for those energy sources. And housekeeping is probably one of the most important things. If the housekeeping program or when you're in a facility and they're using a leaf blower to blow all the dust off the rafters, probably it's not good. Or maybe they're using a vacuum that's a shop vac and it doesn't have that class 1, div 1 or the proper UL listing on it to be in a situation like that could actually be the ignition source too.
So from, say, industrial hygienist or CIH, it's kind of like you guys are probably one of the first to really assess or identify an environmental condition at a location because of the type of work you guys do in a lot of cases. Would that be safe to say? Or
a lot of times you go to a facility and we're evaluating a certain process, and then you ask the question, it's like, have you thought about this process or this material potential being combustible? And a lot of times people say, sometimes they'll say, yeah, no, we've already tested. But sometimes people say, what are you talking about? And it's like, That's when you kind of you got to dig into the weeds and say, we need to do some assessment of what's going on.
Well, what are some of the challenges of monitoring and detecting combustible dust in general industry? I mean, what is it, just the lack of knowledge or the awareness of the dangers of it? What is it?
I think it's a lack of awareness.
And you get into some of the NFPA standards, which Ashok will talk about later. I don't think people are aware of that. And once again, as an industrial hygienist, we go in and we see these situations. And when you have all the history of facilities that blow up, and when you have an explosion, it's usually catastrophic. And you don't want to be on the Channel 5 News with your facility behind you on fire.
Right. And many of these NFPA standards have been around for over a century now. And there's still a lack of understanding or appreciation of the dangers of combustible dust. Like the agricultural dust standard dates back to the 1920s. The polymer dust standard dates back to like the 1930s. There's a huge history, but they're common things that are household goods for the most part: sawdust, food products, fine chemicals that might be, polyethylene, that kind of thing. People just don't consider them as hazards. At the same respect, if you had poured gasoline on your floor, you'd be concerned that you'd have a flammable hazard.
Yeah, they might be concerned about the flammable liquids they have in their facility. They don't think that a particle could be flammable, and you mix those two together, then that even makes it more of a hazard.
Right, you've sort of compounded the hazard.
Hello, ET Nation. I want to thank you for listening to the podcast. If you enjoy the interviews we bring you, please consider supporting the program by visiting my website at seankgrady.com and buy me a cup of coffee. Proceeds will go towards helping me continue producing timely content and offsetting production costs. I'd also like to take a moment and recognize a few of our sponsors of the show who have been amazing partners and who are ET Nation legends. If you're looking for a driller and an environmental contracting firm to help you delineate the extent of contamination at your site, then look no further than Cascade Environmental. Cascade has over 37 offices across the country and offers a huge range of environmental and geotechnical drilling, site characterization, and remediation services. With their huge fleet of equipment and nationwide coverage, Cascade is a great choice to support your environmental and infrastructure needs. To learn more about their company, visit their website at cascade-env.com. That's cascade-env.com. I'd also like to give a shout out to Enthalpy Analytical. If you're looking for a single source for all your laboratory testing services, then give Enthalpy Analytical a call. With their network of accredited laboratories, experienced project managers, chemists, and industry professionals, they have everything you need to support your next project. They can analyze anything from drinking water, groundwater, soil, sediment, sludge, air, and much more. To learn more about Enthalpy Analytical, visit their website at enthalpy.com. That's enthalpy.com. Finally, I'd like to recognize Zappa Stewart, the leading provider of superabsorbent polymer technology for the power, dredging, oil and gas, and remediation sectors for over 20 years. When a reliable, fast, and cost-effective liquid waste solidification solution is needed, customers count on Zappa Stewart's brand of SAPs and technical expertise. When liquid waste needs to be out of sight and out of mind, give Zappa Stewart a call. To learn more about Zappa Stewart, go to my website at seankgrady.com. That's seankgrady.com. Now, let's dive back into this interview.
We talk about awareness. How do we train and educate the industry in the dangers of this type of exposure and these types of hazards? I mean, are there regulations that require annual training or some sort of education to prevent these things from happening, or at least make people aware of it? I mean, I'm curious. So is there OSHA? Is that involved? Or we talked about NFPA, but are there any hooks out there that require this educational aspect of training the people?
Let me take that real quick, and I'll segue to you, Ashok, because there is no OSHA standard, and people don't realize. They think we have a standard for everything. No, there is no OSHA standard, but what OSHA has is they have a national emphasis program that's been going since, I think, 2007. They did try to pass a combustible dust standard, I believe it's 2009, that they rescinded. But within the OSHA national emphasis program, they actually list the NFPA standards, and OSHA, even though they don't have a standard they can cite, they can always cite the general duty clause. They can cite the electrical standard. They can cite housekeeping. There's many different avenues that they use for that citation, but keep in mind when OSHA comes in, usually it's after the fact, because there's not enough OSHA inspectors out there to go out, and there's probably not enough outreach that they do about combustible dust. But it's things like this that hopefully gets the word out, that people, they put that in the back of their mind and say, oh, I didn't think about that as a potential issue. But if you want to talk about some of the NFPA standards, they're state of the art, and they're updated.
Sure, Kevin, and just to build on what Kevin already said, is that OSHA also has a HAZCOM standard. So if you are dealing with hazardous materials, which combustible dusts are, you have a responsibility as an owner operator to inform your employees, whether they're contractual employees or actual exempt or non-exempt employees. You have to let them know that they're dealing with hazardous material. So the other thing, as Kevin alluded to, is that the national NFPA, National Fire Protection Association standards that are out there are all covered under either the NFPA fire code or the International Fire Code, which a lot of municipalities have adopted as their county state fire code. Those documents also talk about training of employees in terms of hazard awareness. So there's either the OSHA guidelines for HAZCOM, housekeeping, electrical area classification, nothing specifically about dust, but you have to warn people about the hazards of dust. And on the other side of it is your fire marshal will make sure that the fire code is followed, and that fire code refers to the fact that you need to follow the NFPA dust codes, 652, 654, 61, 664, 44, 655. And those tell you that you need to train and inform your contractual, exempt, and non-exempt employees.
Yeah, and I think some of the language that they use in those standards and also in the OSHA National Emphasis Program is the authority having jurisdiction. And I think it's exactly what you say, because there might be different authorities depending on where you sit and where your factory is. It could be more rural area where you have a fire protection district and not a fire department, correct?
Correct. And then your building inspectors and maybe even your insurance company, they might come out.
Absolutely.
And want you to have.
I think you made a comment before that you don't want them coming, the fire marshal putting a sticker on your door, because they actually have probably more power than OSHA does. I mean,
OSHA's just going to fine you. They're going to pay, here's a fine. You can litigate it. Your fire marshal, if they find out that you're violating the fire code, they're going to put a sticker on your door or a piece of equipment.
Shut you down.
You can't run it. You're shut down until you fix the issue.
And then you gotta hire a fire protection engineer to go through your whole system to make sure you're in compliance. So yeah, it can be a big issue. And of course, most clients see the cost, and it gets to be kind of the limiting factor.
Well, I think, Ashok, you mentioned, Ashok, the HAZCOM requirement. That's, I think, been overlooked. I mean, combustible dust and the HAZCOM education, I think that's getting largely overlooked, because most HAZCOM is all around spill prevention of hazardous materials associated with a chemical process, whether that's a waste or true commercial chemical products. Maybe electrical safety, right? It HAZCOM as well. Some maybe environments that you wouldn't want to be in that have bad oxygen levels or something like that. But I think combustible dust is kind of like forgotten.
I think it is. Like there's a certain number of trained OSHA inspectors out there that will point that out and find that, but a lot of them just haven't been trained for combustible dust either.
Yeah.
So it's very hard. They may overlook it and not necessarily find it in their own walkthrough inspections.
Sure.
And you might have a local jurisdiction that goes through it, and then they refer to federal OSHA or the regional OSHA people, and they'd have to find somebody to come out your facility. But I think what we talked about with the training aspect is, and I've seen it in facilities before, and Ashok alluded to it, that a lot of times they have their maintenance and janitorial staff are temp employees, or they're hired from someone else. And a lot of times that gets lost in the whole thing, that they're not trained in the program and what the hazards are, and can actually create
more problems.
Exactly.
Right. The obligation is for contractors, exempt and non-exempt.
Yeah, right.
It's defined as an unplanned event. You don't go to work and plan on having an accident, right? But it does happen unless you have the training. I think that's what it all comes down to.
Right.
And awareness is a big part of that.
Bingo.
Yeah.
And
is there any signage?
HAZCOM is always the top 10 OSHA cited regulation.
Is there any signage available out there that you guys are aware of that says hazard combustible dust? I can't recall seeing one, but I mean, maybe there is.
It's there for sale. I mean, if you can find them.
Okay, I'm gonna look it up. We should talk about promoting more of that.
But it's not there on walls of facilities. Kevin, I think you've probably seen this as well. When you walk through facilities, there is no sign for hazardous combustible dust. Combustible dust.
Interesting. Very good. I mean, so things that we're touching on, I think hopefully this is going to start to ring true or pique somebody's interest at their own facility, and they'll go and check things out and look for these types of hazards. If we were to zero in on some specific types of dusts that are included in OSHA's NEP program, what kind of combustible dusts are we talking about? Like, can you name a few of them that would be recognizable?
We can name several, but Ashok kind of alluded to it earlier, that OSHA does have a standard for grain elevators, because grain elevators are one of the classic ones I remember being as a kid, I grew up in a farm area that 70s and 80s that they were exploding, and they jumped on that. But you can have metal dust, aluminum, magnesium, some of those things are combustible, iron dust, wood dust, coal dust, carbon dust, plastic dust, pharmaceuticals, organic chemicals. You can go right down the line, pretty much.
Anything could almost be combustible dust, almost, right?
Anything that can.
What won't combust, Ashok? Do you got an answer for that? I'm trying to think what would not.
Salt won't combust.
Salt.
Go.
Okay.
Certain metals are already oxidized. So if you have like aluminum oxide or iron oxide or silicon oxide, because they're already oxidized, they won't oxidize anymore. Right. And the thing with carbon-based things like plastics and agricultural and wood dust is that they do form carbon dioxide in water if they burn.
Right.
So those are
things like biosolids and textiles. I mean, you don't always think of all these things, but obviously a textile facility is, you could have plastic derived
cotton and wool fibers will
absolutely. Just like the lint in your dryer will catch fire.
Right.
People forget to clean the lint in their dryer.
There you go. I mean, yeah, we're kind of just touching on some of the industries that generate or handle combustible dust. I mean, a lot of times companies or industries are collecting their dust in dust bags, right? Dust filters as far as their process. And so it's an engineered process that they're trying to capture and eliminate this dust in their manufacturing process, right?
And they're concentrating it,
Yes.
Right.
bringing it above like a dilute level. You're taking it from a hygiene level that might be an issue, but then as you concentrate it, it comes above the minimum amount that's required for an explosion, and now you have the possibility of an explosion occurring. Whereas before, if you just blew it outside, this is like before the 70s, this is like 50s, 60s, 40s in that time frame, they would just blow the dust to the outside, and there wouldn't be an issue. But then in the 70s, the EPA came along and said, well, you can't just release this dust to the atmosphere. You have to contain it and dispose of it properly. So people started putting in bag houses and dust collectors and cyclones. And then you collected and you concentrated the dust. You've now had a lot of explosions in dust collectors, whereas NFPA turns them as air material separators.
And then when you put it inside your building, it makes it even more hazardous at the same time.
It's like a ticking time bomb in your building.
Yeah, that's interesting. I mean, I think from an engineering perspective, understanding the hazards associated with combustible dust and not properly managing it could really accelerate some high risks of the explosion in a building atmosphere. I'm wondering how often engineering firms are really looking at that, who are designing these types of systems and control systems or is it being kind of managed internally by a company who wants to just keep it in house, and then they just don't realize that the risks.
Kevin?
I would say that most internal companies aren't going to have somebody that has the training and the knowledge, because I think that's what the NFPA standard says, right, Ashok? You got to be properly trained. You got to be an engineer. You got to have that background to understand what the risks are, because it's not simple building or designing a system that has the potential for combustible dust.
Mm-hmm.
Because you got to make sure you control that. You're looking for that secondary explosion. So you got to have systems that have relief in them, and has to be designed. But like I said, when you have it inside your building,
Mm-hmm.
that's a problem. A lot of the dust collectors that you would design outside the building, right, Ashok?
Right, absolutely. And what we've seen is that compared to, let's say, 20 years ago, 25 years ago, we've seen more people becoming interested. They know that they may not have their own special expertise on how to deal with it,
Right.
but they know that they need expertise. So they reach out to people like us and people like you just to help them understand the codes and what kind of mitigation steps they can take.
Well, okay. So what would be one of the ways somebody who maybe suspects they have combustible dust, how would they confirm that?
The best way is to start off with a screening test.
Okay.
You can go to literature. Sometimes literature is wrong, but start off with a screening test to disperse the material into the air as a cloud and ignite it. And we do it in a safe manner by doing it inside of a closed vessel. But you ignite it, you see whether it reacts or not. If it doesn't react, then you can know well that my material is not a hazard for combustible dust cloud. And if it does react, we have an issue and you have to tackle it. Now, certain things could happen. Certain things might explode as a cloud, but not burn as a pile or a layer, or vice versa. Or the best scenario is that it doesn't burn as a layer and it doesn't burn as a cloud, like table salt would. But certain things could blow up as a cloud and not burn as a layer.
So I mean, what's the sampling and analysis activity look like, and who actually can run these tests?
Well,
Anybody?
We do it, but I think Kevin, as industrial hygiene people, could go around facilities where you do a lot of respiratory monitoring, but
Right.
also you can do monitoring or collection in elevated surfaces on top of equipment and just collect the dust from there or on the floor.
But the problem is you just don't want to go collect one dust, because you might have 4 or 5 different types of different dust within a facility. And if you miss one, that's where this dust hazard analysis come in. So you're looking at all the processes, and you're also looking at, and I don't know if we talked about it earlier, but as you process a chemical, it might get smaller and smaller. So you got smaller particle size, drier as it goes through the process, and then it's going to create more of an issue. So where do you collect the sample? So you got to have some knowledge of where am I going to collect the sample from? You just don't collect it off the floor.
Well, there are guidelines to this. I mean, does NFPA have, I mean, I think they have what's called the dust hazard analysis. Talk about the NFPA requirement around that, and what does that look like for clients to comply with?
That I think is the most important tool that you have. So once you have a combustible dust present, you do a systematic review of your process in your building to find out, like, where's this going to occur? Where could these combustible dust clouds be formed under normal conditions, under upset scenarios? Where could I have a fire? You systematically sort of tackle your process from tip to tail to find out where these hazards could be. And then you test to make sure that you understand, like Kevin said, that maybe the beginning, your dust behaves one way, the beginning part of your process, but your dust is a different particle size, different moisture, maybe slightly different chemistry towards the end of your process, might behave in a completely different way. So you're going to have to tailor your protection and mitigation systems depending on the combustible and reactivity of the dust that you're dealing with in the form that it is.
But you did mention some of the NFPA standards. They have listing of 50 different particles and whether it's combustible or not, and they have some of that information. It is available, but still the gold standard is to go to the sphere.
Correct, but with those tables are generated from data provided to the committee by FM. They're an insurance company that does a lot of testing, and so they have data sets for thousands and probably even tens of thousands of dust.
Right.
And so they've published a limited set in the NFPA standard. But again, those are chimera type of amalgamation where looking at maybe rice flour, they've tested 300 types of rice flour. They just picked and chose interesting values to put into the table. So that may not necessarily reflect your rice flour.
Right.
Your flour might be slightly different.
Didn't we talk about, last I recall, there wasn't a requirement to complete this dust hazard analysis? And that it seems like industry is not really on top of this expectation that is out there from NFPA, right? Is that, am I talking?
The deadline was in 2020.
Yeah,
So,
and we still get calls all the time with people saying, "Do you guys do combustible dust?" And it's funny that you still hear that in the year 2024. You're like, "Yes, we do," and we have people that assess that, and they're mainly engineers, to be honest with you. They're not CIHs, but a lot of CSPs, safety professionals, have a lot of knowledge, and a lot of it goes to those electrical systems. If they understand the different classes of electrical, that's really important, and that's kind of what Ashok is alluding to. That once you go through this dust hazard analysis and you evaluate what your systems are, what is your equipment, what type of electrical do you have, and it has to be protected properly. It's pretty detailed. Yeah. So there's a lot of liability there from your standpoint too.
well, it's kind of surprising. Like, we get calls now 5 years after the deadline. Hey, we've just heard about dust hazard analyses. Do you do them? Could you help us with our dust problem? So even 5 years after the deadline, we have people coming out. And quite frankly, I don't even think that by that deadline, I don't even think like 5% of the companies in the United States have tackled combustible dust hazards.
So what does it typically cost to run a dust analysis test? What, is this a real expensive test, or is this inexpensive, reasonable? What are we talking about?
It's not inexpensive. It's very specialized with a lot of safety precautions around it, because we're creating an explosion that you don't want to have at your facility. So we have to do it in a very safe and controlled way. Sometimes your dust might produce toxic combustion products. PFAS type products might be generated because you have fluorinated plastics that you're blowing up, or they might even be organic materials that have fluorine molecules or fluorine atoms on the molecule. So it could take some time to do the test, and therefore the cost is sort of commensurate with that. So we're not talking tens of thousands of dollars, but definitely.
But for the initial no-go test, it's like 100 or 1,000 grams, right? So just so you understand what you have to have for the test, and if you got to go through the whole litany of tests, you need more material. So it's important to know that when you're collecting a sample, because you don't have to go back if the facility is in another state. Exactly right.
So I'm sure like you've got some, I guess, analytical chemists, or you've got, I guess, customer service people helping the CIH or the engineer at the facility collect the right amount. And is this collected in like a Ziploc bag, or is it a jar, or what kind of way that this comes to you?
I think we'd want to see it in a container that doesn't rupture. So if you double bag Ziploc, that's fine. If you use a non-breakable plastic mason jar, that's fine. If you use gallon paint cans that you can get at Home Depot or Lowe's and just put a plastic bag inside there and seal it up, that would be acceptable as well. And usually, as Kevin was saying, like 1 kilogram of material might be a good collection point, 2 to 3 kilograms, depending on how much testing. And a lot of times that testing is going to depend upon how are you going to protect the system or how are you going to prevent the explosion. And you might need to have specific data for that design, and therefore you might need more elaborate testing. So that's
it also depends on what material you're collecting too. I mean, if it's a highly combustible material, I guess you probably wouldn't want to be sent it in because it's gonna go, but you might have to use nitrogen or something to purge to ship it. So it all depends on what, and that's where the lab comes in to make sure that they get it there safely, and you'll accept it
right
with the chain of custody.
And then, like for example, the inerting it. Sometimes when you have metals, by the time that you've taken your metal off of your surface, ship it to the lab, it might further oxidize, becoming less reactive than it would have been at your facility. So you want to make sure that you're capturing it in the right way to preserve its non-oxidized nature.
Yeah, yeah. So there's some procedures and protocols. I mean, I'm wondering if there's like sampling plans in this and a SAP that you got to put together that this is how you do it properly. And are there guidance documents around that to collect an adequate representative sample?
I don't necessarily, I think the NFPA doesn't necessarily address that other than saying that you need to know your process and know where those unique formulations of dust are generated and sample from there. It's not necessarily like a hygiene sampling plan where you would, by having a monitor near someone's breathable location. It's a little bit more like undefined, and it's really more bespoke as to what your specific process is going to be.
Yeah, right. We talked about previously combustible dust should be included in your HAZCOM program, your health and safety program. It's definitely part of a waste program from, if I'm collecting a bunch of it in a bag house or whatever. I mean, it's component. Would it be incorporated in some sort of a sustainability program? I mean, we touched on this last time, I believe, during our, let's kind of recap on that a little bit. I mean, is there areas that this could be incorporated or should be assessed or supported in that?
Yeah, I think we've kind of discussed this a little bit before, that making sure that you have that sustainability aspect when you're thinking about something that could be combustible, right? So you obviously you don't want your facility to have a catastrophic event. So by controlling that, it's part of that, the whole circle that you have, right? So we want to make sure that we have a health and safety work environment, or a healthy and safe work environment. You want to make sure that your process and what are the three things? Profit and environmental.
Well, there's environmental, social,
and
governance. Yeah, governance. So right.
So in my opinion, it covers all of it. So you want to make sure that you have that. And if you're doing like due diligence, I would imagine it's important if you're doing a due diligence assessment of a facility, you have some knowledge of what combustible dust is. We have people that do that. We've talked about that before.
Yeah.
And making sure you have the longevity, because it's all about the sustainability.
Oh yeah, and you have to keep, like, for example, like a document like a DHA, which might address some of that. You'd have to keep for the life of your process. So whether it's 50 years, 100 years, you're keeping that information along, which is part of your governance. Like, if you are maintaining a safe workplace for your not only your employees, your contractors, but your neighbors as well, the people that are around your facility. Because if you do have a big fire that might have some polymer or pharmaceutical burning, you're releasing a lot of toxic chemicals out to the environment as well, which could adversely affect your neighbors.
Well, and some of this dust, I mean, wouldn't this dust potentially, some of it, have some intrinsic value if it was collected properly? Could be recycled, incorporated into some other product? I mean, in that area?
It's coming from your process. You're either paying someone for that dust, or someone's going to be paying you for that dust. So if you're going to throw it out to let it go to waste, then you're just throwing money away.
So it fits into the circular economy kind of concept here as part of the sustainable managed practice, but just knowing that part of that practice has a byproduct, which would be the combustible dust aspect of managing this material properly. If you capture it well, then it should be part of it and be assessed as part of the whole program. I think it does fit. it's you got to really think about it, but I think it does fit if you do it right.
It's like gold. You don't want to be throwing gold out, right? And whatever
Yeah.
your product is, the raw material does cost money, and obviously rolling it. And in a lot of industries, that they basically grind stuff up and they put it back into the process. So, as I say that, if you have a process like that where you have plastics, for example, where you're going to be regrinding, you can then now create another potential combustible dust hazard by recycling your materials at the same time.
So let's say if after the extruder, you take the pellets, you regrind it up and then put it back in the process, that's creating a lot of dust. And you have to make sure that you're capturing that dust and putting it back into the process without creating fugitive dust. And the equipment that you captured into has to be able to prevent or mitigate an explosion.
Intrinsically safe, right? Yeah, exactly. Well, any specific landmark examples of combustible dust events in the U.S. that might, illustrate the dangers of this for our listeners?
We have like a fantastic government body called the U.S. Chemical Safety Board, which goes out and investigates situations like this. And they've investigated several large dust explosion accidents. The most notorious one, I guess, was in 2008 in Savannah, Georgia, at Imperial Sugar, where a huge facility was lost because of that. But they have had several other ones as well.
I think the facility was destroyed, 14 deaths and 36 injured. And the facility didn't exist anymore. And it happens at grain elevators too. I mean, when a grain elevator goes up, usually they're in the middle of the country, so it's not as big of a deal. But a lot
back
of
in the 80s, which is why the OSHA grain handling standard came out in 87.
Because you kind of get to the point where you can't see your hand in front of your face, and the dust cloud is so bad, there's a potential issue. And I'm sure farmers. I was a kid. I used to go in a grain elevator with my buddy and his dad, and it's like now I think about the dust in there. I wish I would have known that. But a lot of people don't, and farmers probably don't know.
Mm-hmm.
Wow.
And they all store their grain because right now they're picking all their corn and soybeans and they store it and then they sell it next year.
Yeah. Yeah. Well, as we wind this conversation down, let's talk, Lynn, is there anything else you guys can think of that we might want to let the listeners know that are the importance of, or something we haven't really touched on that is like maybe an update that's coming out or anything else that they ought to be aware of? And then two, maybe just quickly mention how the listeners could get a hold of you as they're listening. But I will also include your contact information on my website, and they can get a hold of you that way. But what do you guys think?
Sure. I think one of the major events that are happening is that all the various dust explosion standards are getting amalgamated into one document called NFPA 660. We had a milestone event this past week where nobody voted to put in notification that they wanted to appeal the new standard, the amalgamation of the existing standards. Mm-hmm. And there's going to be November 16th is the last day for the appeals. And then after that, it's going to be pretty much smooth sailing to get the standard into publication. So you might see the new NFPA 660, which is an amalgamation of all the other existing standards into one document, very much like the National Fire Code or the National Electrical Code. It'll be about the size of an encyclopedia volume, but it will be in one convenient document that people can go to, and therefore not get confused with the various documents that are out there and say, well, where should I really go look? So we've generated one document where you could go to for all your combustible dust accident awareness and mitigation and prevention guidance.
Well, that's good to know.
Yeah, and then keep in mind at your facility, the DHA doesn't last forever. I mean, you have to. Is it every 5 years you're supposed to review it, and also as your processes change,
you need to update it as well. It's like your SPCC plan. If you add a tank, you got to update it.
When a truck's talking about the NFPA, I mean that they're constantly reviewing that.
Right.
And OSHA standards are really hard to pass, right?
Yeah.
OSHA has almost an act of Congress to pass a new standard, and one of the last ones it was a silica standard, and MSHA actually. The Mine Safety Health Administration just passed a standard for silica as well. So it's really difficult to get that through government. EPA has a better process than OSHA, but just keep in mind that you need to be up on the process. And a CIH, I mean, we always say, here's your data for exposure, for example.
Right.
But if you change your workforce, your processes, the chemicals you're using, you have to reevaluate. But no, and a lot of those NFPAs get codified into local fire codes. They're in the OSHA National Emphasis Program as well, so they do have backbone.
And unlike OSHA documents, where like OSHA sets up a standard, it's like an act of Congress to change it. The NFPA standards, you can have public input in them, and they're renewed every 3 to 5 years, depending on the cycle. So you get a chance to have your say. And then the technical experts on the committees then review your comments. And if there's merit, they make adjustments or look into it even further. And if it's already covered, they'll say, it's great that you brought this up, but it's covered in this chapter or that other chapter, and you should go look there. But it's a very dynamic process.
You get stakeholder buy-in, right? You have stakeholder buy-in on the NFPA standards. The same thing happens with EPA and OSHA. You always have the group that's going to challenge it, and some people like it and some people don't. But I think combustible dust is something everybody can pretty much agree on, Sean.
Yeah.
And if the NFPA technical committees are made up with a lot of different stakeholders, it's not just one group of people that are in there. There's manufacturers and there's insurance companies, there's code enforcers, there's a lot of people, consultants like us as well.
Right.
Yeah, I think we did touch on insurance last time, and I can't recall exactly the scenario there, but I got to imagine quantifying, understanding your combustible dust exposure would help with some sort of an insurance.
They're trying to avoid risk.
If risk.
I've seen some of the checklist forms from the different insurance carriers, and of course they're going to look for what those potential risks are because they're risk adverse.
Oh, absolutely.
And most industry, getting back to your sustainability, should be concerned about it as well because it's a real thing.
Well, let me ask you this, Kevin. You're the CIH here on the call. I mean, I'm a CHMM, and I know we cover hazards, and I'm pretty sure we cover combustible dust as a topic. But does the CIH credential cover a topic or two on combustible dust in your credentialing certification process?
No, I would say no. I mean, I know many CIHs that I work with and that are peers of mine, and most don't really deal with combustible dust, more for workplace hazards. And once again, as a CIH, you kind of got to know what your limitations are. I'm not going to design a ventilation system because I don't have the PE stamp to put on a ventilation system, and I wouldn't want to design a ventilation system, especially if there's combustible dust. So there's things that, it's just like we talked about the ocean inspector. Some people are really good about welding as a CIH. Some people are good with mold. Some people are good with the indoor air quality or other different facets of the practice. Well, we practice industrial hygiene, and people forget about that, and it's highly variable. When you go to a facility for one day and you collect a set of samples, you have to assume that's representative. Is it always representative? No, I'd like to be there every day, but that's not realistic. But to answer your question, most CIHs, unless we have a lot of CIHs that are also engineers. And if you got the PE behind you, then they would be more inclined to do more of the dust hazard analysis or getting more involved in the engineering side of it.
Yeah. That's good. Well, gentlemen, I really appreciate you guys coming on to the show. I think this was a good, lively conversation of elevating the awareness of combustible dust to our listeners. And I really appreciate you coming. Dr. Dastidar, how do people get a hold of you?
The best way to get a hold of me is dust@fauske.com. DUST@Fauske, FAUSKE.com.
All right. And Dr. Aikman, how about yourself?
All right. It's pretty simple. It's K Aikman, KAIKMAN at rambol.com, RAMBOL.com.
All right, gentlemen. I will get you guys' contact information also posted up on the website so people can track you that way as well. Really appreciate you guys coming on, and thanks for the conversation around combustible dust and also being part of the 100th episode of the podcast.
It's a 30 feet, baby.
Appreciate you guys.
Thanks for listening and watching the show. If you enjoyed the show, then please share it with your friends and coworkers on social media and tell somebody in person. Thanks for being with us, ET Nation.